Good morning, friends. This is a series of lecture for TYPSC Analytical Chemistry Semester 5 2019 pattern. And in this video, we are going to learn about the chapter number 1, Gravimetry or Gravimetric Analysis. In previous lecture, Gravimetric Analysis, we have already learned about the principle of gravimetric analysis. Especially, it deals with the study of weight, where weight is obtained in terms of pure form as possible of a specific element from the different composition. This is the principle of gravimetry. Now here next topic is common ion effect, and we are going to learn common ion effect. What is the statement of common ion effect? When a strong electrolyte containing common ion with weak electrolyte is added into a solution of weak electrolyte, the dissociation of weak electrolyte is suppressed or decreased. This is the statement. Now what is electrolyte? Electrolyte is nothing but it is a substance which conducts electricity. Now here a strong electrolyte dissociates completely into aqueous ions, and its solution conducts the electricity, while weak electrolyte does not dissociate into aqueous solution or dissociate partially, and electricity passed through weak electrolyte is also poor. Now when such a substance, that is two substances, one is strong electrolyte, another is weak electrolyte. When a strong electrolyte containing a common ion with a weak electrolyte, that means both contains a common ion, and it is added into a solution of weak electrolyte. When strong electrolyte is added into solution of weak electrolyte, then dissociation of weak electrolyte is decreased or suppressed. So that is a common ion effect. Now here, when a weak electrolyte is acetic acid, suppose it is acetic acid. Acetic acid is a weak electrolyte, while sodium acetate is a strong electrolyte. When a strong electrolyte, sodium acetate, is added into a solution of weak electrolyte, acetic acid, then dissociation of weak acid, or you can say weak electrolyte, that is acetic acid, is suppressed. Here acetic acid is weak electrolyte and sodium acetate is a strong electrolyte. Similarly, second example is ammonium chloride and ammonium hydroxide. Now here ammonium chloride is a weak electrolyte and ammonium hydroxide is a strong electrolyte, and both contains a common ion NH4+. Now here in the previous lecture, in the previous example, acetate ion, that is CH3COO-, here CH3CO-, and here also CH3CO-, that is sodium acetate has acetate ion and acetic acid has acetate ion, both has common ion acetate ion. So here that is common ion effect. Now here in this example also NH4+ in ammonium hydroxide and ammonium chloride, NH4+ and NH4+ both has NH4+ ion which is common in them. So ammonium chloride is a weak electrolyte and ammonium hydroxide is a strong electrolyte. Now this strong electrolyte NH4OH, ammonium hydroxide, is added into a solution of weak electrolyte, that is ammonium chloride. Then dissociation of weak electrolyte, that is ammonium chloride, is suppressed or decreased. So that is, we can say, accordingly common ion effect. Now why this happens? And common ion effect has a practical importance because it gives a common method to for the analysis of the mixtures. So we can easily verify the inorganic compounds with the help of common ion effect. So that is application of common ion effect. Again, this common ion effect takes place because of Leachate principle. Now, what is Leachate principle? When we apply the system at equilibrium, and when we try to disturb this equilibrium situation of this any system, at that time with respect to concentration, pressure or temperature, then the system nullifies the effect of concentration, temperature, or we can say pressure. So that is the Leachate principle, and this common ion effect takes place accordingly with the effect of Leachate principle. So this is all about the common ion effect, application of common ion effect, and example of common ion effect. With this content, I conclude this lecture. Thank you very much for your patience listening.